Yo, welcome to the stream. Today we will be taking a look at enumerations and pattern matching. So, particularly we will see how to use enum and what are the use cases for it. Then we will take a look at some useful enum called option, and then we will consider we will take a look at match expressions and also this if let construction. So, let's get started. I hope stream is fine. Yeah, looks like. So, the enums can be defined as structs, means in the same kind of syntax but using enum keyword. So, when can they be useful? See, here is one example. If we want to, have a data structure for properties of IPs can be of two types, at least as of now. It can be either version 4 or version 6, but they can't be of same type at, at the same time, right? So this makes enum perfect for use. And so we can declare a enum like this using enum keyword and then specify its name. Here we are saying IP address kind. And there are two variants of this enum. One is version 4 and another is version 6. These variants are separated by comma. So that's how we declare an enum. And when we want to create an instance, we just say use this double colon syntax because these variants are under this namespaces. So we say of IP address kind we need version 4, same with version 6. Here we can create any instance, and you can probably see right now, just we can't have same a variable of both type, like this 4 can't be of version 4 as well as version 6 at same time, right? It can be either version 4 or version 6. And what is use of making them enum is that even though they are of different version, but basically they are just IP addresses, right? We want to treat them the same way. So if we have some function like route which we will use for routing some traffic, we can just pass this kind of enum. We can just specify the enum because we know enum are kind of like our own data types. This is now our custom data type, and this function will now work for both of them, like for version 4, also for version 6. This is the one advantage of enum, right? It can make much more sense. And now, as we have the types, it makes sense to have IP address with it also. So one way we can do is we can declare another struct here, right? Because as of now, what we know, we can have a struct which will have two parameters or two fields, we can say, to be more precise. One will be kind, and this will be of our enum type, which we declared here IP address kind, and address will be string. And while creating instance, we specify kind to be version 4 and address of localhost, and same with loop back here. So this is a nice way, but it's like unnecessary thing. We can actually specify this data inside of enum itself. We don't need to use struct. We can, while declaring an enum, we can add the values it will associate it with itself. Like version 4 will have its associated string. Version 6 will have its associated string. And then while creating an instance, we can just create it with that string value, right? We can say version 4 and then we specify its IP to be localhost. Same with loopback. And one more advantage is that these don't have to be of same type. These two don't have to be of same type. We can just specify any type, like version 4 can be also written as like 4 unsigned 8-bit integers, because it is going from 0 to 255 at max, so we can use unsigned 8-bit integers for that. So this doesn't matter, like we can have different types inside an enum. And this this enum to represent IP address is so common that a standard library has it by default. They have defined it inside their standard library. If you want, we can check it out and see how they implemented it. Basically, they also did the same thing. And most of the time, whatever is implemented in standard library, it won't be much different from which we will manually implement. So this is, and one thing to note that this doesn't come in scope by default unless we bring it inside our scope, like we did with the random number in our casing game. Therefore, we can use our struct here without any name conflicts. But if you want to use the standard one, we just have to import it, or bring it in our scope. And we bringing types into our scope will be covered in the chapter 7. And as we just saw, this can be of any types. Let's take a look at another example here. We have an enumeration called message. It can be quit, which has no data associated with it. It can be move, which have an anonymous struct inside it. It can be either write, which will be associated with a string, or it can be change color. And yeah, if we had to implement this using struct, we would have to write this much code. Like we have to declare a separate struct for quitting message, separate struct for move message, separate for write message, and same with color change message. And this is everything for message only, right? So it make much more sense if we just implement them all in one place. And this is where enums come really handy. We can just implement them all at once. And what is I didn't get that question. Sorry. Anyway, so yeah, this can be either quit or move, but can't be like both messages at same time. So that's when you consider using enums over struct, and this is how they come really useful. And as we did with structs, yeah, I'm a student in currently. I will go in second year, like in month or so, in few days. We can also so back to our topic. We can implement this as we did with structs. We can also implement the methods with enums with exactly same syntax. We will use the implementation block, and inside it we will declare methods, and the first parameter for method is going to be self. Like here we create an instance of message of variant write and pass it associated string to be hello. And when you call this method, the self will be this part, the same as the variable m, because it's calling itself. And we can do anything here with self, or we can just do anything. So this is how enums work, or can be used in various ways. And if you have something to ask, you can just let me know in chat. I will be happy to answer. And there is very useful enum called option, which comes by default in the standard library, and it has some advantages over null values. Rust doesn't have null values. Like you might have seen other languages having null value. The variables can either be null or they can't be null, like not non-null values. But Rust doesn't have non-null value. It implements the same methodology with option enumerator. You can read it why they don't want null, because null can cause a lot of bugs. Like you might have some value which you think is not null, but it can be null and you might handle it wrong when that will lead to many bugs. And it is easy to fall in that pitfall. So instead, Rust doesn't have that null value. Instead, it uses the enumerator called option. Option have two variants. It's either some value or none value. So it can be either something or nothing. And if you ask what is this T, it is generic type. So which will be which we haven't talked about it yet. It will be covered in chapter 10. But for now, all it all we are for our concern, it can be of any type. It can be integer, it can be string, like any type for now. So as we know, there can be only two variants. It can be something or nothing, which is none. Here is an example. Like we can declare some number to be some 5 or some string to be option of some a string. And notice we didn't use, like for this enum, we had to use this message namespace and then double colon to specify right variant. But here we are just directly using some, because option enum is so commonly used that Rust compiler made that available for us without having to write all that syntax, right? So, but we can say some for you and it will make the type of option to be I32, or you yeah, default is I32. We didn't specify any type, so it will be I32. It this time it will be a string literal. But here, when we want to assign none, we have to annotate the type of the option. Like we have to specify the value for the T, because it can't tell what will be the value of when there will be some value. It doesn't know its type, right? From none, it can be integer, it can be string, it can't tell. So if you want to declare with none, we have to tell its type. Like when there will be some value, it will be of type integer. So we have to do it like that. For declaring some value, we can forget about this type annotation. We just have to do it for the none. And you might ask, like, we are still using none, and here also we are using null in other languages. So what's really advantage over it? Well, the advantage is, because we are using it from option enum, option T and normal type. So we can say, for sake of example, option of I32 and I32 will be of different type. They are not of same type. Here is another example. If we declare x to be 8-bit integer of with value 5 and y to be option of type 8-bit integer, and we are saying it to be some 5, and if we try to add them, you can see Rust compiler gives an error because it doesn't know how to add 8-bit integer with option type. There is no implementation for that. And this is how you will catch none values if there are any. So while compiling Rust compile, if Rust compiler sees like I8 or some predefined value, predefined type, it will be sure that this won't ever have a none value, right? It will have to check only if there is option. This I8 can never have any null value. Only this option, there is possibility of having nothing, so it will have to check for that only. And same with if you want to access the value inside of this, like suppose we wanted to access the value 5 out of this option, there are many methods for that which are implemented on option enum. We can take a look at its documentation here. I will open it in another tab. Here, these are the methods implemented on it. Like you can see, there are a lot of methods, and it might be worth it to have a look at them when you have time. But for now, we will move ahead. So this is how option increase the safety of Rust code, and it allows us to write our code more confidently. Now we saw that enums and option enum. Let's let's now move to the control flow part, which is match expression. Here, match expression is like very powerful. It goes line by line. So instead of it's explaining the what is match expression, and we can use anything with it like literal values, variable names, wildcards. But let's see an example. Here, suppose we can write a function that can take an unknown United States coin in a similar way as a counting machine and determine the coin and return its value in cents. Like here, we had a enum called coin, and these are four possible values of a coin. A coin can be either of these. And inside of value in cent function, here we are taking a coin enum. As we saw, we can take this type as a function parameter, and we are returning an unsigned 8-bit integer, which will be the number of coins in what we want to return coins in cent. So every match statement consists of arms. Like this is an variable, and these are all the arms of match expression. Here every arm consists of two parts. First part is an what we say, this is a pattern, and next part is code which will get executed if pattern match, and match statement goes in order. So what it will do is it will take value of coin and try to match it with coin of penny variant. So if it matches, it will execute this code, which is just an expression 1. So it will basically just return 1. If it matches, it runs the code and well, it's done. If it doesn't match, however, so it will move to the next arm. Here, it will try to match with nickel. If it match, the same thing. If it doesn't match, it will move to the next arm. And this is how match statements work. We also saw them in our guessing game for handling error. And if we want, instead of just here one line of code, if you want to have multiple line of code, we can actually use it like this. Here, you can use curly brackets to specify multiple lines of code which you want to execute if it's a match here. So I think, yeah, let me try this code. If we call it this function with coin, so for now, first call it with time. It's running. Yeah, you can see it went here with this value. It tried to match with penny, it doesn't match. It tried to match with this, it didn't match. And it in the third arm it matches, so it executed this code which was 10, which basically returned 10. And if I now try to call it with penny, now see what happened. It printed lucky penny. So it goes in this arm, first arm, it found a match, so it will execute this code, which was print line this and then return this expression. That's what happened here. It printed this code and then returned 1, which gets printed here. So this is how you want to execute a lot of code, you can just do that instead of match statement. And you can also bind some values. Suppose here in this, if you want like to have this country state name alongside with it, yeah, state name, so you can have inside of definition of coin enum, you can say the quarter is associated with the state name, which is just another enum. US state is another enum which consists of state names. So we have to change our match coin, right? If you see that state, we want to print that state. So what we do is just as we declared in enum, we have to specify it in brackets here, state. So what it will do, if quarter gets called, like the value in cents function get called with quarter variant, it will come to this arm, it founds a match, and then it will assign the associated state with this state variable, and now we can use it however we want. So this is how we associate the state, and let me quickly copy it. And here, let's see an example of it. So we are calling coin quarter and passing state Alaska. Now if we run it, this is just warnings for unused code, but you can see here it printed the state quarter from Alaska. What happened here is this enum, this value of enum get associated to state variable here, and then we accessed it here. So this is how you access the passed in value inside of match statement, and this doesn't need to be just an enum, it can be anything. So yeah, this is how we do it. And as we saw, option is just another enum, so we can use match with it too. And there are only two possibilities, one is none or some. So we can use it like this. Suppose we have a function called +1, which just adds 1, as its name says. It accepts an option and returns an option type. Here we declare 5 to be of option and then call the function with it. So when this will be called at this line, it will go try to match it with none. It doesn't match, so it will move to the next term. Here it found a match, so it will make I to be equal to the 5, and then it will return sum of 5 plus 1, so which will be value 6. And this is how it's going to work. And when we call it for none, it matches with none and returns none, because we don't have to add 1 if value is none. And one thing to note here is that matches are exhaustive. Like we just can't implement for half of variants and skip the rest. Right? Here, for example, for option there are two variants. One is sum and there is another none case. And we have to implement both. If we didn't have to, it will be a bug. It might cause a bug. But luckily, Rust compiler just won't compile that code if we didn't handle it. Here, you can see if we just implemented sum type and skip the none type, it will tell us you have not covered this type, you have to cover that. So, and it can be like if our struct, sorry, not struct, if our enum was lot bigger, like here, if you want just 1, 3, 5, 7, and we don't want any other values, we can just use this underscore, like we did in error in the guessing game. We can use underscore placeholder. It acts like a wildcard, so it will match any value. So we can just implement our code for values we want, and for remaining can just use underscore. And here this is called as a unit value, which basically does nothing, right? We only care about this. And you might notice here it is written at 0 u8, which is same as 0 of unsigned 8. You can specify type either here after variable name, or you can just do like this with integers. And so if let is just another match, like convenient way for match statement. So here if you only care about one value, which is 3, writing this much is like kind of overkill. So this has lot of boilerplate code. Instead we can just use if let. What if let does is take a pattern and a value separated by equal sign. So if this matches, it will execute the code inside of block. It's simple, right? Just that simple. If sum 3 and this variable matches, which is 0, in this case it won't match, so it won't print anything. So we will play it with in playground. So if I run it now, it just won't match. So it should do nothing. And now if I change our value to be 3 and now run it, you can see it printed 3 because this time this expression matched and it printed 3. So this is how it can save a lot of boilerplate code from match statement. Same, and we can also use else block for it. Like if you want, so you might say if it's not 3, and for the rest of thing just print not 3. And now if I run it with 0, it should print not 3 if there are no errors. Yeah, it is printing not 3. And one thing I told is 0u8 is basically same thing as doing this. It is same thing. We can either specify it here or just use it as prefix for our variable. So that's how if let works, and we can also have an else statement with if let. So this was it. We see how enums are used and what are their use cases. We saw option type, and we used match statement, which are very powerful for control flow, and also saw if let. If you have anything, you can just ask in chat, or I will just end the stream. And by this, like it's almost been 10 episodes, I guess, and we have covered language like kind of basic level, so we can just get started with making our own projects. So yeah, I will end it. See you later.